The Georgia Electrical exam covers a range of topics with residential, commercial, and advanced considerations. For residential, you'll need to be familiar with wiring methods, including types of residential electrical wiring, conductor sizing and insulation, circuit protection, and grounding. Lighting and branch circuits require understanding lighting calculations and design, branch circuit requirements and protection, and load calculations for residential buildings. Other important areas involve ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or SIs, as well as smoke and carbon monoxide detectors. For the commercial portion, wiring methods include commercial electrical wiring systems, conduit sizing and installation, cable trays, and bus ducts. Lighting and branch circuits require knowledge of commercial lighting design and calculations, circuit requirements and protection for commercial buildings, and load calculations for commercial buildings. Other important topics are emergency lighting and power systems, fire alarm systems, transformers, and electrical equipment. The journeyman exam includes all of the residential and commercial topics plus more advanced areas. This involves industrial electrical wiring systems, three-phase power distribution, and motor control circuits, as well as high-voltage systems, safety procedures for high-voltage electrical work, transmission and distribution line installation and maintenance, and substation equipment. The exam format includes 50 multiple-choice questions for residential, 55 multiple-choice questions for commercial, and 100 multiple-choice questions for journeyman. You'll have 3 hours to complete the exam. Here are some general tips to help you prepare. Firstly, study the Georgia Electrical Code, which is based on the current version of the National Electrical Code, or NEC. Secondly, understand electrical concepts. Focus on the fundamentals of electricity, such as Ohm's law and circuit analysis. Thirdly, do practice questions. Take practice exams to familiarize yourself with the question format and test your knowledge. Fourthly, join a study group. Collaborating with others can help you learn and retain information. Fifthly, consider attending a review course to prepare for the exam. Finally, on exam day, bring pencils, a calculator, and a copy of the NEC. Delving into wiring methods is essential. This encompasses understanding the various types of wiring used in residential, commercial, and industrial settings. This includes Romex, or non-metallic sheath cable, commonly used in residential buildings, conduit, which can be rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and flexible metal conduit, or FMC, and cable trays and bus ducts, which are often found in commercial and industrial applications. Conductor sizing is determined by the ampacity, which is the current carrying capacity of the wire, and is based on factors such as the load requirements, ambient temperature, and the type of insulation. NEC Table 310.15 provides guidance on conductor ampacity. Insulation types such as THHN, THHW, and XHHW are rated for different temperature and environmental conditions. Circuit protection involves the use of circuit breakers and fuses to protect electrical circuits from overcurrents and short circuits. Grounding is crucial for safety. It provides a low impedance path for fault current to return to the source, stripping the circuit breaker or fuse and preventing electrical shock. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock by detecting ground faults and quickly interrupting the circuit. Arc fault circuit interrupters, or SIs, protect against fires caused by arcing faults. Smoke and carbon monoxide detectors are vital safety devices that provide early warning of fire or carbon monoxide hazards. Lighting calculations involve determining the appropriate level of illumination for different spaces, taking into account factors such as the task being performed, the size of the room, and the reflectance of the surfaces. Branch circuits supply power to individual outlets, lights, and appliances. The NEC specifies the maximum number of outlets or lights that can be connected to a single branch circuit. Load calculations are performed to determine the total electrical load of a building or system, which is used to size the service entrance, feeders, and branch circuits. For commercial lighting design, understanding various lighting technologies such as fluorescent LED and high-intensity discharge, or HID, is very important. You'll need to calculate lighting levels using foot candle requirements based on the area usage. Emergency lighting and power systems provide backup power in the event of a power outage. These systems typically include generators, uninterruptible power supplies, OPSs, and battery backup systems. Fire alarm systems detect fires and alert occupants. These systems include smoke detectors, heat detectors, pull stations, and audible alarms. Transformers are used to step up or step down voltage levels. Understanding transformer connections, such as delta and Y, and transformer ratings is essential for the exam. Motor control circuits are used to start, stop, and control electric motors. These circuits may include components such as contactors, relays, and motor starters. High-voltage systems require special safety procedures due to the increased risk of electric shock. These procedures include wearing appropriate personal protective equipment, or PPE, and following lockout/tagout procedures. Transmission and distribution lines carry electricity from generating stations to substations and ultimately to consumers. Substation equipment includes transformers, circuit breakers, switches, and other equipment used to control and protect the electrical system.